Okay, so the goal today is to hope you know what makes rollout different and know what account abstraction is about. Okay, so layer 2 solutions and rollup. What is layer 2 solutions? So layer 1, we have a block space, which is really scarce resource, so it's very expensive. So the idea of layer 2 is to move the execution and data off chain of layer 1, and we only submit the result of the execution on chain. So that's why layer 2 is fast and cheap. And what are those rollouts? What are layer 2s? We have many layer 2 solutions. There are many, but here I will only mention 3 of them. The first one being sidechain, second one Plasma, and the last one is the rollout. Okay, so what's the difference between sidechain and Plasma? Sidechain is run by operators, and you enter and exit the sidechain with operator's permission. For Plasma, it's also run by operators, but now you enter and exit Plasma via a smart contract. So the rule to enter and exit is written in smart contract instead of full permission from the operator. And so in Plasma, operator will periodically submit state rule on chain, and you will exit the Plasma by providing proof. This could be like Merkle proof to prove that you own $100 on the rollup or on the Plasma, sorry. And you also can challenge invalid exit. So what's the downside of sidechain? The problem is that you can only trust the operators, which is a big problem. For Plasma, you still need to trust the operators, but only to a certain degree. The operator, however, cannot just take away your money. So what's the difference between Plasma and rollup? In Plasma, operator can censor your transactions. Operator can withhold transaction data so that you cannot verify correctness of state root. In rollup, just like Plasma, but all the transaction data are submitted on chain. So you can verify the correctness of the state root. And you also can challenge invalid state and prove state valid. So the problem of Plasma, as we mentioned, is that you still need to trust operator to some certain degree, but the operator cannot just take away your money. For rollout, operator cannot do any damage but to degrade a system performance by providing a shitty service and then going vote it out, which is really nice. Okay, so a recap on rollup. All the data will be made public, and so everyone can compute and verify the state himself. And in rollout, it can also guarantee the state validity via 2 approaches. The first approach is by fraud proof or full proof. So you will use a proof to challenge invalid state. The rollout that does this approach is called optimistic rollout. And the second approach is the validity proof, where you prove your state is valid by providing a zero knowledge proof. And this kind of rollout we will call validity rollout, which is also known as ZK rollout. So what's so important about rollout is that it shares the same levels of security as layer 1. And you can build different VMs on rollups. It doesn't have to be EVM. You can build every VM on you can possibly imagine on rollup. So the catch is that you should definitely build a rollup instead of another layer 1, because your rollup is as secure as layer 1. For example, Ethereum, where it's secured by billions of dollars on layer 1. And besides, its security is also way faster and cheaper than layer 1. Yep, so that's the introduction of layer 2 solutions and rollup. Now we'll have a quick overview of the current rollups. For optimistic rollup, there is a problem, which is the challenge period, and it's currently 7 days for both Arbitrum and Optimism. And so it's a bad user experience. So you have to have third-party bridges to help improve this problem. For example, Hop, Orbiter, or MakerDAI bridge. You shorten the period so that user doesn't have to wait 7 days to get their funds back to layer 1. And ideally, this challenge period can be made adjustable according to how congested the layer 1 is at the moment. For validity rollup, currently the problem is that the proof generation is very slow, but don't worry, we have recursive proof to improve the speed and reduce the cost. For rollup in general, the problem would be that submitting data on-chain is and or will be the major cost to rollup. And so some rollup may choose not to submitting data on-chain. For example, if you do this in optimistic rollup, if the data becomes unavailable, users will lose their fund, which is quite a problem. And rollup, live example of this kind of rollup is Nova. And if you're a validity rollup and you want to not submitting the data on-chain, and if the data becomes unavailable, users' fund will get stuck. And the example of validity rollup doing this is the Starware's Validium and ZK Porter from ZK Sync. Okay, so what else can we do to reduce the data cost? For rollup itself, you can apply the data compression algorithm on the data. And for layer one, it can help by implementing these two approaches. The first one is the EIP 4844. It's also called pro downsharding. And next one is the real big deal, the downsharding, which would dramatically cut down the data cost. Okay, so anyway, you should check out the l2b.com. This website is awesome. It has layer 2 data like TVL and also has security overviews for different rollups. So anyway, a rollup is very awesome. So build on rollup instead of building another layer 1. Okay, so next topic is the account abstraction. So now, what we are we have like when a node receives a new transaction, it will check the sender nonce and the sender signature. And nonce is used to determine the transaction ordering, and signature determines how transaction is authorized. And these rules are hard-coded at the protocol layer at the moment, so there is actually no flexibility. And that's the problem. So what account abstraction is doing is to abstract away how your transactions are ordered and also how you authorize the transaction. And so in account abstraction, you can customize these logics in your contract instead. For example, you can have parallel transactions for transfer, for swap, for loan, or other DeFi operations. You can you can have a queue of nonces for each action or each category of these operations. And you can also have your own customized signature schemes, for example, RSA, or using an aggregated signature like BOS, or use a ZK-friendly signature scheme, or post-quantum secure signature schemes. Anyway, you are a contract, so you're not just a pair key anymore. You can do so much more than just a pair of keys. You can implement any logic you want. So since everyone is a contract, so you definitely include the benefits of contract wallet. Like Gnosis, for example, the benefit includes multi-calls, where you can do approve, swap, deposit, stake, all just in one single transaction. And you can also do social recovery, and it's an additional helper to combat your private key loss, private key theft, or any other constant logics you can think of. But there's also definitely drawbacks and challenge to account abstraction. The first one being the DOS attack risk, because now the node need to actually execute the transaction to find out if the validation passed or if the contract has enough to pay for the gas fee. And another downside is that it will bring a drastic change to the protocol. And talking about this problem, we have EIP 2938, where it poses drastic protocol change. But in another EIP 4337, it doesn't bring any protocol change to account abstraction. It's purely account abstraction on the application layer. So a little bit about the EIP 4337. So there's mainly one important thing is that instead of a transaction, Ethereum transaction, we have user operation instead. It's just like a normal Ethereum transaction where you can do simple transfer, you can do element swap, you can do DeFi ops, etc. Just like a normal Ethereum transaction, but instead it's in another format. And you, for example, you want to transfer Ether, you would forge, you will craft your own user operation, like filling in who you are, how much you want to send to who. And then the bundlers will bundle user operations and send this batch of user operations to miner. And so users will pay the bundlers from the user's contract in ETH or other ERC20 tokens instead, which is nice. So in account abstraction, what's the difference to what would the user experience look like in account abstraction? So first, your identity on chain is a contract instead of your public key. And key pair of the money works is no longer an essential part in this design. So, and also you will be able to use mobile or other common device to sign transactions securely instead of trusting another wallet app. Okay. Cool. Final part, account abstraction on rollup. So rollup actually has great incentives to adopt account abstraction since it has little error compatibility problem for them because they are really new. And especially for validity rollout where you implement less features in the protocol means you get more flexibility. So there are currently 2 validity robots that has implemented account abstraction on them. The first one being StarNet, and the second one is ZK-Sync. So today I will only cover StarNet. So in StarNet, the transaction authorization is abstracted away. It means you can implement different signature schemes or other transaction authorization scheme in your contract. But the nonce is not abstracted away for maybe simplicity reason. And also to mention in the past, since StarNet has ECD as a algorithm over a star curve instead of the Ethereum curve, which is SECP 256K1. So that means in the past, we don't have Ethereum wallet support like imToken or MetaMask cannot support account abstraction on StarNet because they don't use the same curve as Ethereum. So then we have different companies building StarNet specific wallet like RGNX, Bravos, and MetaMask Next. But now the software team has built a library specifically for SECP 256K1 over ECDSA, and they also built the KCHA, and now so actually the Ethereum wallet can support the StarNet account abstraction now. So in StarNet, there are a few problems, like every user must deploy his account contract first, and that address must first have some Ether to deploy. So which is kind of a problem because you haven't deployed the contract yet, but you have to have the Ether first. We can solve it. Maybe the deployer can cover the costs, like the wallet can cover the deployment costs and maybe charge the user later. That's one approach. But anyway, so in account abstraction, there is no more import private key than go because private key is not tied to a certain address right now. Only the contract is, so we can no longer do this easy import private key or export private key approach. Some problems currently in the StarNet I would like to mention is that they don't have a gas price option for you to prioritize your transaction, but it's not air related. So the second problem is that it doesn't yet support user paying fee in ERC20. There's also the benefits to account abstraction, just like I mentioned. First one being the multi-core, where you can have multi-actions done in just one single transaction. And second one is the social recovery. Third one is the really nice features called plugins. And here I will have an example called session key. So session key is a key with more fine-grained capabilities. Maybe when you use session keys, you doesn't use your private key to sign many things over a duration of your dApp usage. Instead, you have create a session key just for this specific dApp, and you can specify capabilities